Okay, so we're starting this second video on number 6, solving the system. The easiest way to solve systems is to do linear combinations. We're going to combine the lines. So when we combine the x's with the x's, negative 10 and negative 14, we get negative 24x. When we combine this positive 3y with this negative 3y, they eliminate. That's why it's also called the elimination method. The equal sign comes down, and negative 107 minus 85 is negative 192. So now we have a simple one-step equation right here in red. Up here we had two variables, x's and y's. You can't really solve that, but now that we have one variable equation, just an x, we could divide both sides by negative 24, divide both sides by negative 24, and we will get our first answer, x equals positive 8. Okay, so once we have one answer, what do we do to find the other answer? We plug it in. So we're going to take this value of 8 and plug it in into the top equation right here into the x position. Again, we're plugging into the x because this is x equals. If I would have solved for y, then I'd be plugging it into the y. But because it's 8 equals x equals 8, we plug it into the x. So let me rewrite that top equation right here on the side. We have negative 10, but instead of times x, we're going to put times 8. And we still have the plus 3y equals negative 107. So now we have an equation that we could solve for y. We end up with negative 10 times 8 is negative 80, plus 3y equals negative 107. Let's get rid of that minus 80 by adding 80 to both sides. We end up with 3y, actually let me do it in a different color, 3y equals negative 27. So our final step would be to divide by 3, and we will get y equals negative 9. So our answer is 8 comma negative 9. That is our solution to that system. If we were to have graphed the top equation and the bottom equation, we'd get two different lines, and those different lines would intersect at the coordinate 8, negative 9. Let's move on to number 7. Jumping to number 7, we're going to be solving this system. However, there's a typo. Let's first change that typo. This 55 should be a 52, okay? 55 should be a 52, or else it won't work out. Sorry about that. Now let's take a look at the system, and we can see that it's not like number 6. Number 6, we had it ready for linear combinations, for the elimination method. How do I know it was ready on number 6? Because we had the x's on top of the x's, the y's on top of the y's, the equal on top of the equals, and this is all mixed up, right? This y's on top of the x, this equal sign is all jumbled up. So linear combinations is not optimal for number 7. We do have a single variable on one side of the equal sign. So y equals this stuff, and because there's a single variable equal to some stuff, the optimal method of solving the system is to use substitution. So y equals this binomial, 4x plus 14. So I'm going to take that 4x plus 14 and I'm going to plug it into the other equation into y. Okay? Now if this would have said x equals 4x plus 14, or 4y plus 14, then I would plug it into the x. Again, because it says y equals this stuff, I plug it into the y. If it said x equals this stuff, I would plug it into the x. So let me rewrite this bottom equation. So I have a 3x, I have a minus 2y, but notice I'm putting parentheses because I'm going to plug in the 4x plus 14, equals 52, not 55, remember that was a typo. So we're going to plug in the 4x plus 14 right into the parenthesis. And what that does, when you substitute, it changes this bottom equation, which had two variables, an x and a y. It changed it to a single variable equation. It's just x's, right? And since we only have x's, we could solve this equation. So let's do so. Negative 2 times 4x is negative 8x. Negative 2 times positive 14 is negative 28. Bring down the equal sign, bring down the 52. Bring down the 3x that's out in the front. Let's continue by combining like terms. 3x minus 8x, that will be negative 5x. Let's bring down the minus 28, bring down the equals, and the 52. So let's continue solving by getting rid of that minus 28. We're going to add 28 here. We're going to add 28 over here. So we have a new equation that reads negative 5x equals 70, 80. final step would be to get rid of this multiplication of -5 by dividing by -5. And we will get our answer x equals 16, -16 that is. Now that is half of what we need. That's barely our x value. So the y value is easy. Whenever you have x and you want to find y, whenever you have one variable and you want to find the other variable, all you have to do is simply plug it in. I want to plug it into the top equation, y equals 4x plus 14. Let me write that. Y equals 4x plus 14. And again, we're going to take this 16 and plug it right in there. -16, that is. So 4 times -16 is -64. And we still have to add 14 to it. So y equals -16 plus 14. And the final answer is y equals -50. So the correct solution to this system is x equals -16, y equals -50. And of course, you could write it as a coordinate -16 comma -50. Number 8, we need to graph this thing. It is a parabola. It's a quadratic trinomial equation. It's in standard form. So we know that we need to find the vertex first. And how do we find that vertex? We have to use the vertex formula, x equals -b over 2 times a. This is kind of where we wish we had vertex form. It's really easy to find the vertex when it's in vertex form. Anyway, how do you use the formula? You have to replace the variables with parentheses. And let's identify our a value is 1, our b value is 5, our c value is -1. So we are going to have something really funky. We're going to have a 5 over 2 times 1. So our x value of our vertex is -5 over 2. Now, what is -5 over 2? Well, 5 divided by 2 is 2.5. So our x value is really -2.5. Okay, but for the sake of plugging in, I'm going to leave it as a fraction. So I'm going to say x is -5/2. But when I graph, I'm going to be thinking x is -2.5. So on the vertex coordinate, I want to put -5/2. And once I have my x and I need my y, all I have to do is plug it back into the original equation with parentheses. So let me zoom in a bit. Here's my original equation. I'm going to rewrite it. It's going to be right here. Y equals x squared plus 5 times x minus 1. And like I said, we're plugging in that fraction that we got for the x value of -5/2. -5/2. So some people are going to be freaked out right now because we have fractions that we need to work with. It's pretty easy. Let's think about this first term, -5/2 squared. That's really just -5/2 times -5/2. So what do I really get on this first term? I get positive 25 over 4. Now let's take a look at this second term right here, 5 times -5/2. Well, that's really 5 over 1 times -5/2. So for that middle term, we will get a -25 over 2. Okay, and of course, let's not forget about the c value, the -1 at the very end. So let's put -1 over here at the very end. Now this right here is actually pretty challenging. Multiplying fractions, that's pretty easy. 5 times 5 is 25, 1 times 2 is 2, 5 times 5 is 25, 2 times 2 is 4. Multiplying fractions is easy, but when you're adding or subtracting fractions, that gets a little challenging. Okay, so we need to subtract those fractions. In order to add or subtract fractions, you need a common denominator. So you need to look at the 4 and you need to look at the 2 and think, what number could I convert both of those numbers to? And of course, 4 is the common denominator that you want. Now, how could you change 4 to become a 4? You don't, right? This guy's already ready. So this 25 is going to stay exactly the way it is. Okay, now this other 2 over here, how do I change a 2 to become a 4? I multiply by 2. So I have to do the same to the top, multiply by 2. So I really have 25 take away 50 over 4. 25 over 4, take away 50 over 4. And I still have the minus 1 over here at the very end. So right now, let me focus in on these two fractions, 25 over 4, take away 50 over 4. I'm going to get negative 25 over 4. Because remember, when you have a common denominator, you just simply do the top take away the top, or the top plus if you had a plus. So 25 take away 50 is negative 25, and it's still over 4. And we want to subtract 1 from it. Okay, so if we want, I mean, there's different ways of approaching this. If we want, we could convert the negative 1 to negative 4 over 4, so we could have a common denominator. So let's do that. Let's convert it to a negative 4 over 4. And now that we have a common denominator, I mean, everybody agrees, right, that 4 divided by 4 is 1. So now we have a common denominator. We could say negative 25, take away 4, that's going to be a negative 29. Negative 29 over 4. Now, unfortunately, negative 29 over 4 doesn't work out nicely. So we need to convert this to a mixed fraction, or you could just do it on the calculator to get a decimal. I want to show you how to do it without a calculator. So if you go 29 divided by 4, now we already know our answer is going to be negative because it's a negative. 29 divided by 4, 4 times 7 is 28, and you have a remainder of 1. So it's always remainder over the original divider. And let's remember that this is going to be a negative, okay? So this is our y value, negative 7 1/4 of our vertex. The x value is negative 5/2. So let me go over here and put negative 7 1/4. And we need to graph this vertex. So to make it a little bit easier to visualize where it belongs, the vertex will be, let's change the decimals, negative 5 over 2. Negative 5 divided by 2 is really negative 2.5. And negative 7 1/4 is really negative 7 1/4 of the way, which is 0.25. Of course, if you got a calculator and did this divided by 2, you'll get that, negative 7. And then times 1/4, you'll get that. So let's go and graph this vertex of negative 2.5. So we're going to go negative 2.5 from the origin. Negative 1, 2, and then halfway. And then we're going to go down negative 7, 6, 7, and 1/4 of the way down. So it's like right here. It's not even halfway down. It's right here at 1/4 of the way down. So let's plot that point right here. I know this is the weirdest we've ever graphed. And we're going to draw our axis of symmetry right through that vertex. Okay, so the axis of symmetry is x equals negative 2.5, even though they're not asking for it. Now, at this point, we know it's going to be opening up. The a value is 1, so we could use a pattern 1, 1, 2, 4, 3, 9. But that is kind of confusing because we're out here in between actual integers. So a better thing to do, so if you did want to use the pattern, it would be kind of confusing because you would go 1 over and you'd be right here, and then 1 up and you'd be right here, right? So you could put a dot right there if you want, 1 over, 1 up, and it's right there kind of floating in space. And then you go back to the vertex and you go 2 over and 4 up, 1, 2, 3, 4, and you're kind of floating right there in space. And of course, you can go back to the vertex and go 3 over, 1, 2, 3, and you're over here in the halfway point. And then you go up 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. Then of course you could map over the coordinates to the other side, but you have to count. Now remember, it's at the halfway point. So think about this. We have half, and then 1, 2, and then another half. That'd be 2.5 plus half is 3. So from here, go 3 to the left. So 1 at the halfway point, 2, 3 at the halfway point. So let's put a dot right there. And then map the other one over. This one is half, 1, half, so that's 2 units, right? 1 unit to that halfway point, another unit to that halfway point. So 1, 2, put a dot right there. And the last one is 1 unit away, because from this halfway to that halfway, so it's 1 entire unit away, so go 1 unit this way and put it right there. All these coordinates are kind of weird because they're floating in space. So the best thing to do, especially if we're taking a multiple choice test, is to, well, first let me graph it and then I'll tell you what's the best thing to do, because this is already going to be graphed for you on the multiple choice. So the best thing to do is to find your y-intercept value. Okay, so you should already know your vertex because we found it. It was kind of confusing because of the fraction. So you know that it's down here. You know it's opening up because the a value is 1. We know that it's not too narrow. We know that it's not too wide. We know it's a regular U-shaped curve because the a value is 1. But what you could also do is find the y-intercept. Now remember, this is the y-axis right here, and you want to find out where it crosses, right? So if you want to find out where it crosses the y-axis, you could find the y-intercept by setting x equal to 0. And that's really easy to do because if you set this x equal to 0 and that x equal to 0, your c value is going to be the only thing left. So 0 squared, 5 times 0, 0 plus 0 is 0, 0 minus 1 is negative 1. So it's kind of like going back to the xy table and finding out what your y-intercept is. And how do you find the y-intercept? By setting x equal to 0. Now when you do set the x equal to 0, you get out a negative 1 for the y, and that coordinate is right here on the y-axis, 0, negative 1, right there. So on your final exam, of course, you're going to have 4 graphs, and the best thing to do is to look at your a value. You know it's positive, so it's opening up. You'll be able to eliminate some answers just by the ones that are opening down. You could eliminate those. Then on top of that, you could find your vertex, and on top of that, you could graph it like this, or you could also find the y-intercept by setting x equal to 0, and you'll find out where your parabola crosses the y-axis, which is at this coordinate. And with that information, you will be able to identify which is the correct answer. Number 9, it is an exponential growth function. I don't know if we remember this, guys, but exponential functions look like this. Y equals a times b, the base, to the x, and in algebra 2 we're going to have a minus h up here in the exponent position, plus k. Okay, the hk is kind of like the shift. It's kind of like the vertex on a parabola, but this is not a parabola. Okay, so what we're going to do is ignore the k value. There is no h value, so let me erase that so nobody gets confused. We're going to ignore the k value for a while. The k value is going to be your asymptote. I hope we remember. This was way back when at the early part of the semester. So we're just going to focus in on y equals 2 to the x power, and we're going to make an xy table. Okay, everybody follow along with me, please. So we're going to plug in some numbers. If I plugged in 0, I'm going to put 0 in the middle. What's 2 to the 0 power? What's 2 to the 0 power? 1. Anything to the 0 power is equal to 1. Of course, you could use calculators. You'll see that it equals 1. What's 2 to the 1 power?
2.
What's 2 to the 2 power? 4. What's 2 to the 3rd power? 8. Come on, guys. 2 times 2 times 2 is 8. Now, also, if you go backwards, if you go on 2 to the negative 1 power, I hope you remember that 2 to the negative 1 power, the negative exponent, it's really a fraction, and you need to take that top negative exponent term and move it down. So 2 to the negative 1 power is really 1 over 2 to the 1, which is really 1/2. Okay? And if you plug in a negative 2, you get a 1/4. Okay? If you plugged in a negative 3, you get a 1/8. Now, I hope this is starting to click to you guys. Remember, the b value is the growth factor or decay factor. If the b value is greater than 1, it's going to grow. If the b value is less than 1, it's going to decay. It's going to approach a certain value from left to right. So what's the base right here, guys? What's the base? 2. So it's definitely going to grow from left to right. Now, you didn't have to do all this math that I just explained. You could have said, let's plug in 0, and we get out a 1 because 2 to the 0 is 1. And then after that, because you have consecutive integer inputs, we're going to be able to use the pattern, not the pattern, but the growth factor of 2. So when you plug in 0, you get out a 1. When you multiply 1 times 2, you get 2. Times 2, you get 4. Times 2, you get 8. The next one would be 416. The next one would be 532 if you keep multiplying by 2. Does that make sense? Going backwards, it's not multiplying by 2. It's the inverse, which is dividing by 2 or multiplying by half. 8 times half is a fourth, times half is 2, times half is 1, times half is half, times half is 1/4, times half is 1/8. Make sense? So we just need to get, not really all of these coordinates, but we do need to get the understanding of them. So now let's start graphing. Now remember guys, we ignored the k value. So this is the parent graph. So we're going to graph the parent graph, and then we're going to shift all coordinates. Where are we going to shift all coordinates?
5 units.
5 units down, because it's a -5. Perfect. Okay, so let's start graphing the parent graph coordinates. 0, 1 is right here. Let's go to 1, 2. Okay, 1 on the x, 2 on the y, it's right there. 2, 4, 1, 2 on the x, 1, 2, 3, 4 is right there. 3, 8. 3, 8 is all the way to the edge. Now, if we go in the opposite direction, -1 on the x and halfway up. Think about that. -1 on the x, halfway up. It's right there. And then you go -2 and 1/4 of the way up. That's even closer to 0, right? And we should know that the next one this way would be half of that, and then half of that, and half of that distance. And it looks like it actually touches, but we know it never actually touches. It just infinitely approaches. Is this starting to ring bells? Are you guys remembering this? I hope. Now, this is the parent graph, so I'm not going to actually draw it. I need to shift all these coordinates 5 units down. Why was that so ugly? There you go, 5 units down. So I know that this is the asymptote, so my new asymptote is going to be 5 units down. So I might as well draw a line like if it's actually touching the y equals -5 line, but we know it doesn't actually touch, it just infinitely approaches. Let me take this coordinate right here and move it 5 units down, which would be right here. Let's put a dot right there. Then the next one, I'm going to shift it 5 units down. This next one, shift it 5 units down. And this last one, let's shift it 5 units down right here. So our blue dots are our final graph that we actually needed. Put an arrow on it. That is your exponential growth function that got shifted 5 units down. Okay, now once again, there are certain tricks that you could do to get this answer quickly on the final exam. For example, if this is 2, then you know it's greater than 1, and from left to right it will be going up. Some of them will be from left to right going down. That would be a decay function. You could eliminate those instantly, right? Not only that, if your a value is positive, it's opening up. If your a value is negative, it'd be going down, right? So we need to know those things. It'll help us identify the answer quicker. Last one. Finally, one that's a little easier and a little quicker. It's solving an equation, a quadratic equation. And of course, we want these quadratic equations equal to 0, not equal to 84. So let's subtract 84. Let's subtract 84. We will have k squared minus 5k minus 84 equals 0. And because the a value is 1, I'm going to at least attempt to factor it and then split it and solve it by putting a k here and a k there, because k times k is k squared. So now all I need to do is think of the multiples of negative 84 that if I combine together give me -5. Now it might not even be factorable, and if it's not factorable, we'd be forced to use the quadratic formula. But let's try it. -1 times 84, -2 times 42, -3 times 28, and I did do that with the calculator. Let's go with -4. 84 divided by 4 is 21. And 5, not going to work. 6, let's say 84 divided by 6 is 14. Let's go with 7. I don't think that's going to work. Yeah, let me see. 84 divided by 7, it does work. 12. Good thing I have a calculator. So -7 times 12. And that's about all the possibilities to get 84. And of course, a calculator definitely does help. Which pair of numbers combines together to give you the middle value, which is -5? If you add negative 1 plus 84, you get 83. That didn't work. If you combine the negative 2 and the 42, that'll give you a 40. That doesn't work. Down here, if you combine negative 7 and positive 12, you will get a positive 5, but you know you want a negative 5, not a positive 5. You have the right number, you just have the wrong signs. So you better change those signs. Change that to a positive 7, change that to a negative 12, and you're good. Positive 7, negative 12, and you're good. We factored it, and now we're just going to split it and solve it. So again, that's a zero product property. This times this equals 0. That means that this first something could be 0, and this second something could also be 0. So let's write that out. K plus 7 could equal 0. K minus 12 could also equal 0, which means on the top equation, K, why did I put X? K could equal negative 7, or it does equal negative 7. And down here on the bottom one, K does equal positive 12. So those are your two answers for number 10. Did we have to factor, split, and solve? No. You could have used the quadratic formula. If you're more comfortable with the quadratic formula, go for it. But whenever I see that the A value is 1, I like to factor, split it, and solve it. I want to continue with number 11 on the next video.